Alright, boom, we're back with our introduction into the subject, trigonometry, and we're covering the 6 trigonometric functions. Random, but somebody commented on another video asking me what be in my mug. It switches up. Today is ginger turmeric. It's really good, I promise you. I bet. So because of the fact we're doing an introduction into trigonometry, we want to start from the basics, right triangles. So here I'm drawing a typical generic right triangle, and we indicate it's a right triangle by drawing the lines to make that little box in the corner. So the reason why a right triangle is a right triangle is because that box is a right angle, and a right angle means 90 degrees. I bet. So even though the right angle is very important in trigonometry, it's still not the main character. The main character is the angle theta, because that's where all the mathematical magic happens. And this angle theta is some other angle in the triangle that's not 90 degrees. In fact, we could take it a step further and say theta is the angle less than 90 degrees. And that's because when you look at all the angles in a triangle, the sum of the angles in a triangle has to add up to 180 degrees. Now think about it. Think about the right angle. The right angle is already 90 degrees, right? The right angle is already consuming 90 degrees out of the 180 degrees. And then we have 2 angles left, 2 angles remaining. One of them being theta that I indicated, and the other angle which I did not indicate in the upper corner. So if we got 2 angles left and we have 90 degrees left to go amongst the both of them, theta cannot be an angle 90 degrees or greater than 90 degrees, because then that's the same thing as saying the total amount of degrees in a triangle could be something greater than 180 degrees. And we all know that's mathematically impossible. Therefore, we can say theta is some angle that has to be less than 90 degrees. I bet. Now's the perfect time to introduce the first 3 trigonometric functions we're covering today. The reason why these functions are so important for right triangles is because they relate the angles within the triangle to the lengths of the sides of the triangle. And we're going to label the lengths of the sides A, B, and C. Cool, so the sides have names. So looking at theta, the side that's opposite theta, A, is what we call opposite because it's on the opposite side of theta. The next one, B, is called adjacent because it's right next to theta. Adjacent means right next to, So B, we call the adjacent side. And C, we call the hypotenuse, which is the longest side of a right triangle. The hypotenuse is the longest side of the right triangle. I bet. So the first 3 trig functions that relates the angle theta to the lengths of the sides of the triangle are sine, cosine, and tangent. Now, the way we express these functions mathematically, for the first one, sine, the way we write it out is to write sin and then theta. So this is how we write out the sine of an angle theta, sin theta. Then for cosine, we write cos theta, or you can call it cos theta. And lastly, for tangent, we write tan theta, tan theta. Now that we got the trig functions for the angle theta, we need the equations to relate the sides of the right triangle to the angle theta. That's what we're about to get into right now. I bet. So for sine, theta is related to the sides of the right triangle, A for opposite, and C, the hypotenuse. And it's related by A divided by C, or A over C. For cosine theta, it's related to B, the adjacent, and C, hypotenuse, as B over C, adjacent over hypotenuse. And then finally for tangent, tangent theta is opposite over adjacent, A over B, A divided by B. Now, something I want to point out is that tan theta is actually equal to sine theta divided by cosine theta, and you can see by how the sides are related. Sine theta is A over C, and cosine theta is B over C. Now, if you look at this division, C is in the denominator in both the numerator and the denominator, so they cancel out, and you get A over B tan theta. So it's consistent, but let me write it out just so you can see. You get A divided by C, and if it's dividing B divided by C, you flip that and multiply it so you can see the C's cancel out, and you get A over B, all right? All right, bet. So something very important I feel like I need to point out. With these three trigonometric ratio equations, for whatever class you take in Algebra 2, pre-calculus, or calculus, typically speaking, teachers do not provide these equations on your exams. This is something you're gonna have to memorize. Thankfully, we have a mnemonic that I've been using, we probably all been using from middle school, sogotutoring, all right? So corresponds to sine, and you know sine is opposite over hypotenuse. That's where the so come from, right? Then you got ka. Ka is C, so you can imagine it's corresponding to cosine, right? And then with cosine, it's adjacent over hypotenuse. That's where the CAH come from. And then obviously, the last one, you got tangent theta, and you know tangent is opposite over adjacent. All right, so just remember sogotutoring and you'll be fine, I promise you. Cool, so that's pretty much all I needed to talk about for the first three trig functions. Now we're gonna do the last three. All right, so we got cosecant, we got secant, and then the last one we got cotangent. Their mathematical expressions are the following. Cosecant, we write CSC theta, right? Secant, we write SEC theta, and for cotangent, we write COT theta. We call it cot theta. Now, these three trig functions are related to the first three trig functions, all right? So cosecant is related to sine theta in the way that it's 1 over sine theta, or the reciprocal of sine theta. Secant theta is 1 over cosine theta, or you can call it the reciprocal of cosine theta. And then for cotangent, cot theta, you can imagine, is going to be 1 over tan theta, or of course, the reciprocal of tan theta. So you can see all these three trig functions are reciprocals of the first three trig functions. So mathematically, the reciprocal means flipping the numerator and the denominator, right? So for cosecant theta, instead of A over C, you're gonna have C over A, the reciprocal of sine theta. For secant theta, the reciprocal is gonna be C over B, right? Then of course, for cotangent, you're gonna flip the A and the B to get B over A. But you know me, I like to be completely thorough with any breakdown I do. And I feel like I want to be extra thorough with the concept of reciprocal. So for sine theta, the reciprocal of sine theta is 1 over sine theta. And then we can express that in terms of the ratio, 1 divided by A divided by C, right? So you know 1 is the same thing as saying 1 divided by 1. And then you bring down that A divided by C. Now, the same thing we did over here with these letters, we apply that same concept over here. So 1 divided by 1 times C divided by A. And of course, 1 times C is C and 1 times A is A. So you get C over A, and that's the reciprocal of sine theta, which is cosecant theta. And you can do the same for the rest. I bet. So we're pretty much covered with everything we need to get into for solving problems, except for one more thing. And this thing we're probably all familiar with since middle school, and that's the Pythagoras' theorem, or Pythagorean theorem, Pythagorean theorem. I think I'm saying that right? Yeah. And it's a theorem about right triangles that relates the three sides of the right triangle in an equation, all right? So the way they're related is by the simple formula a squared plus b squared is equal to c squared. Opposite squared plus adjacent squared is equal to the hypotenuse squared. And you can solve for the hypotenuse to say that c is equal to the square root of a squared plus b squared. All right? All right, bet. Let's get into our first problem. For each right triangle, find the values for the 6 trigonometric ratios of theta. All right, so you know me. The first thing I'm doing, I'm writing out all the formulas 100% of the time, especially for a class like trigonometry or algebra or pre-calculus, because again, typically speaking, we're not provided with the formulas on the exam. These are things that we're gonna have to memorize. And again, we got stuff like sogotutoring that can help us memorize these formulas. So we got the first 3 trig functions that we talked about, sine, cosine, and tangent, and we memorized them from sogotutoring. Then you got their reciprocal trig functions, cosecant, secant, and cotangent. And of course, they're reciprocals because we just flip the numerator with the denominator. And then you got the 3 sides of the right triangle that correspond to A, B, and C, opposite, adjacent, and hypotenuse. And that leads us to the Pythagorean theorem, a squared plus b squared equals c squared. Now, let's get to the problem, the first problem. I bet. So we got a right triangle with sides A equal to 7, B equal to 24, and we don't know what C is. We can use Pythagorean theorem to get the value of C, and then from there figure out the values of the 6 trigonometric ratios. I bet. So let's start with the Pythagorean theorem. A is equal to 7, right? So a squared would be 7 squared. B is equal to 24, so b squared would be 24 squared. Now 7 squared is 49, and 24 squared is 576. Now we add these to get 49 plus 576 is 625. All right, so 625 is equal to c squared, and we want to solve for c, therefore we got to take the square root on both sides of the equation. To get the square root of 625 is 25. C is equal to 25. Now we have all the values of the lengths of the sides of the right triangle. Now we can start getting the 6 trigonometric ratios, right? So sine theta is opposite over hypotenuse, A over C. Therefore, it's 7 over 25. Then we got cosine theta, which is adjacent over hypotenuse. Adjacent is B, 24. Hypotenuse is C, is 25. So cosine theta is 24 over 25. Then lastly, we got tan theta, which is opposite over adjacent. Opposite 7, B adjacent 24. So tan theta is 7 over 24. All right, the next 3 trig functions are the reciprocals. Reciprocal of sine theta is cosecant theta, so that's 25 over 7. Reciprocal of cosine theta is secant theta, so that's 25 over 24. And reciprocal of tan theta is cotangent theta, so that's 24 over 7. Simple, easy, done, we're done. I bet. So for problem 2, it's going to be a little bit different compared to problem 1. So this time, we don't know the value of B, but we're given the value of A opposite and C the hypotenuse. C is 41 and A is 40. So we're going to just work a little algebraic manipulation magic and solve for B. Then once we get what b is equal to from the Pythagorean theorem, we do our little plug and chug. And then, of course, from then on, then we can find all the values of the 6 trigonometric functions. All right, so I subtracted a on both sides so that it cancels out on the left side of the equation so that we get b squared is equal to c squared minus a squared. Then we're going to take the square root on both sides of the equation so that we get b is equal to the square root of c squared minus a squared. Now we can do our plug and chug, right? So c is 41, so we got 41 squared minus a is 40, so it's going to be minus 40 squared. All right? 41 squared is 1,681, and 40 squared is 1,600. So 1,681 minus 1,600 gives you 81. And you know the square root of 81 is 9. So b is equal to 9. Now we got all the values of all the lengths of the sides of the right triangle. So now we can find the values for the 6 trigonometric ratios. Sine theta is a over c, so that's 40 over 41. Cosine theta is b over c, so that's going to be 9 over 41. Tan theta is a over b, so that's going to be 40 over 9. Now we got the first 3 trigonometric ratios. Now we can get the rest, which are the reciprocals of the first 3, right? So the reciprocal of sine theta is cosecant theta, which is going to be 41 over 40. Next, we got the reciprocal for cosine theta, secant theta, which is going to be flipped around to give you 41 over 9. Lastly, we got the reciprocal for tan theta, which is cotangent theta. That's going to be 9 over 40. Easy. Done. We're done. All right, bet. So last problem I want to do, I want to continue from here and just throw a little Uno reverse in there. What we're going to do is show love to that last angle in the triangle that we haven't really paid attention to at all up until this point. So let's label this angle alpha. Now, when you look at alpha, the opposite for alpha is b, right? Now for theta, b is adjacent, but for alpha, b is opposite. Now, what do you think a is going to be for alpha? It's going to be adjacent, but you know, for theta, a is opposite. Now for c, it doesn't change. Hypotenuse is the longest length side in the right triangle. And whether we're talking about alpha or theta, c is always going to be the longest length. I bet. So let's get the 6 trigonometric ratios for alpha. So sine alpha is opposite over hypotenuse, which is b over c, and b is 9, and the hypotenuse is 41. So we get 9 over 41. Cosine alpha is going to be adjacent over hypotenuse. Adjacent for alpha is a. So a is 40 and c is 41. So cosine alpha is 40 over 41. And then lastly, tan alpha is going to be opposite over adjacent, which is going to be b over a. And b is 9 and a is 40. So tan alpha is 9 over 40. Then the rest of the trig functions, which are going to be the reciprocals, is going to give you cosecant alpha is going to be the reciprocal of sine alpha, which is 41 over 9. Then for secant alpha, we flip cosine alpha, which is going to give us 41 over 40. And then cotangent alpha is going to be the reciprocal of tan alpha, which is going to give you 40 over 9. Now take a look at all these values. For cotangent alpha, that's equal to tan theta because tan theta is also 40 over 9. And then when you look at cosecant alpha, which is 41 over 9, you see 41 over 9 is also equal to secant theta, right? And then when you look at secant alpha, which is 41 over 40, we see 41 over 40 is also, for theta, is cosecant theta. And you can probably find more relations between alpha and theta that I didn't point out. You could drop a comment and point out other alpha theta relations that I haven't pointed out, all right? Or you could just drop a comment if you want to show love for the channel. I greatly and truly appreciate it. And you know, Sogo Education got one-on-one private tutoring or a small group tutoring, all right? Just contact us at sogotutoring@gmail.com. I keep that email in the description too, all right? Like and subscribe. You already know what to do. Peace.